this unit, what we have for this one, we're going to start with matter. And it's going to be broken up into 2 recordings. So this is part 1 that we have. And first of all, the question I want to pose to you is, what is matter? Think about that one. Okay? So when we look around on the earth, everything that is around us is made up of matter. And basically matter is anything that takes up space, volume, and has mass. And we're going to look at the 2 types of matter. We're going to look at 2 classifications of matter, and then 4 states of matter. So we're going to go through all this. Okay? So the first of all, there are 2 types of matter. There is homogeneous, and then there is heterogeneous. So when I look at homogeneous, looking at the root word homo, that means the same. And so homogeneous means things that when you look at it, it looks consistent, the same throughout, that you can't see where it came from. So it looks uniform. And when I look at heterogeneous, it's made up of different particles, and I can see all the things that make it up. So let's look at these images below for homogeneous. So what we have right here, water. Water is a great one right here because when it pours out, it's the same throughout. Rubbing alcohol. Kool-Aid. Kool-Aid, even though I mix the drink powder in there, it is the same. It's uniform all the way throughout. But heterogeneous would be this one, the Chex Mix particles right here, where I can see all the different components, the pretzels, and the different types of Chex items there. Okay, some examples of homogeneous, again, we got Kool-Aid, iced tea, or tea, hot tea, it could be the same. Rubbing alcohol is the same throughout. Water, as we pour it, the elements, any of the elements on the periodic table, these are just listing a few, and any compounds. NaCl stands for salt, and Kf is potassium fluoride. And we'll go over compounds later, not in this unit. Okay, examples of heterogeneous are cereal. Most of your cereals that you have, such as Lucky Charms, or some of these other types of Captain Crunch with other things in them, where you can actually divide it out. Look at the Skittles that we have right here, a tossed salad, snack mix, kebabs on the grill. You can see all the different things that makes up. Italian dressing, I got to shake it up and all the different herbs and particles that are in there. M&Ms, different colors, and even milk. Think about that one, milk. If you leave milk in the refrigerator, eventually it's going to settle out and then you get the real thick, chunky parts. I know. Ooh. All right, the next one. So now let's go through each of these and let's determine, is it homogeneous or heterogeneous? So what I want you to do is to pause this, and what I want you to do at your seats is try to figure out what you think each of these are. Are they homogeneous or are they heterogeneous? So I'm going to pause for 5 seconds. All right, so let's go through this. First one, soda pop. Because it's flat and it's not carbonated, this one right here would actually be homogeneous. Cherry vanilla ice cream. This is this image over here with this in the cone. You can see the bits and pieces in there. That is heterogeneous. Soda pop, carbonated because of the bubbles and the fizz, and I can see the bubbles. That would be heterogeneous. Sugar, right here, sugar. It's all the same. It's granulated. It's all the same. That would be homogeneous. And also look at that. It's a compound right there. Salt, right here, it's granulated just like sugar. I can see the different parts, but it's the same color, texture, and look at that. It's also a compound. It is homogeneous. Okay, city air. You see that right there? It's kind of cloudy, kind of hard to see. So that would be heterogeneous. The soot in the air. Iron. This sword right here is made of iron right here. Your scissors have iron in there, even though it's stainless steel. But it is considered homogeneous. It's the same throughout. And beach sand down here, beach sand has all different grains and grits and different particles on there. That would be heterogeneous. Okay? Now, there are different classifications of matter. Matter could be a mixture or it can be a pure substance. Now, if it's a mixture, basically I'm going to put together two or more things together, and I can easily, and let me get my pen here, I can easily separate it, okay? Make sure highlight that one. On this one, it can be heterogeneous or homogeneous, but the example here, homogeneous mixture, would be like me putting sugar and water. The sugar dissolves and it's throughout, and that would be homogeneous. But if I put sand in water, I can see the sand in the water, and that would be heterogeneous. Whenever I can see the bits and pieces and particles, it's heterogeneous. When I can't, it's probably more so homogeneous. Okay? Now, a pure substance is one that's in a fixed composition. That means it has its own unique structure. Okay? So when I look at a pure substance, basically it is only homogeneous. Okay, only homogeneous. So on this one, a pure substance would be elements that you find on the periodic table or compounds like the sugar and salt that we had out there as well. And examples, neon gold, water, which is a compound, and alcohol, rubbing alcohol, which is a compound as well. Now, let's go through the different types of pure substances. An element are those single units. It's one thing, a substance, that cannot be broken down into anything simpler. Okay? So an example would be neon, gold, helium, could be hydrogen, any element on that periodic table. Compounds, though, are where I take two or more of those elements and chemically combine them. That means I've got to go through a chemical reaction to combine them, such as water, salt, and sugar, or rubbing alcohol. All of those are examples of compounds. Okay? Now, if I have a mixture, now let me go back. Mixtures would be, going back right here, these things put together that are a little bit easier to separate it. There are ways I can separate it. And the first way is by filtering. And take a coffee filter. You put coffee in there, you pour water over it, the water turns kind of blackish in color. Well, that means that the coffee grounds are left behind, but the coffee flavor is infused in the water. Okay? So, on there, if you have suspensions, that's a way to separate it. Evaporation is another way. What if I have put sugar and water together and I want to get that sugar out? How do I do it? Okay, you could boil it or you can let it just sit there, and over time the water will evaporate out and you're left with the sugar at the bottom of the bowl. Distillation is another setup that we have right here. A lot of times if I want to separate it out, like they do this at the beach, you want to separate the salt from the water. And you want to have good drinking water, you're going to boil the water. The steam will rise, and then basically it will travel down this tube, and it will go from a steam back down to a gas, and therefore you have that distillation process. It's where separating something that is dissolved in that water. And the last one is chromatography, where you basically can separate the different colors on there using that principle. All right, now, what we have right here is physical properties. Now, if it's a physical property, it's a way for me to describe a substance based on its physical appearance. So it's a characteristic of a material that can be observed, so I can see it, or measure it, such as me measuring volume, and density, and I can measure its mass, how much matter's in there. All of those are in there without changing it. So all of these examples. Now, one is viscosity, and viscosity is a rare property, or not a rare, but it is a unique property in that it shows how fluids, how different liquids actually will flow. Honey and oils and syrup or molasses have a high viscosity. That means these are special liquids that kind of flow very slow. They resist that movement. Okay? They also have another physical property is its appearance. Also its hardness. Conductivity is seen if it can actually produce electricity. Malleability is bending or hammering it into a shape. You see a blacksmith making horseshoes. They'll take metal, they'll heat it up, and then they can hammer it into a shape. That means it's malleable. Melting point, like melting chocolates, and boiling point, boiling water. Those are all examples of physical properties. Okay, now to undergo a physical change, that means you're going to change a substance, maybe its appearance or its shape, but without altering or changing the actual composition, what it's made out of. An example right here would be boiling water. You can boil water and it changes it from a liquid to a gas, but you can take that gas and kind of condense it back down and you can get liquid, you can get water back. Melting. Think of water. You can melt the ice cubes. Let's say I freeze the ice, okay? Freeze the water, it turns into ice, okay? Freezing could be another one. And then you could take that liquid or take the ice cubes, melt it back down, and it goes to a liquid. It's still water either way. Ice is water. Dissolving it, like taking sugar and putting it in water, and it disappears, it dissolves. But if you evaporate out that water, you can get the sugar back. Shredding paper is still paper. It still has that consistency with the paper. Tearing paper. Another physical change, cutting your hair. Your hair is going to grow out. Or cutting the grass out there. It's still going to grow out. It's still grass. It's still your hair. Okay, a chemical property is basically looking at the characteristics of a substance, how it has changed from one substance into another, seeing it undergo a chemical change. An example, we'll go to examples, but flammability is one. Having the ability for a substance to burn. Combustibility, that means materials that will explode. And also reactivity, when you mix two things together and it actually will combine and create a brand new substance. Okay, so some chemical change examples, you're changing it into something brand new and different, and some examples or signs that something has undergone a chemical change are these. Now, color change. Now, color change means it initially was blue, but then when you add some items in there, it changes it to a brand new color. Not me identifying, hey, you're wearing a blue shirt. That would be a physical property right there, me wearing a color there. But a color change means maybe me dyeing my hair because it's gray hair and I want to get a different color in there. Another one, production of gas. Now, this is not boiling. Boiling water, you see bubbles, but that's just releasing, changing it from a liquid to a gas. What I mean by production of gas is that fizzing. Like when you drop an Alka-Seltzer tablet into water, it fizzes. Or when you put vinegar in baking soda and it bubbles up. That's what I mean there. Now, forming a precipitate. A precipitate is basically when I mix two things together, it forms this solid, and the solid will fall out. When you mix these two things together, you get this solid that forms at the bottom of the container. And also, if you can get a release of energy. So like here, we have these glow sticks over here. If you, inside there's this little glass tube inside these glow sticks, and you have to break it. And it releases this chemical and it produces this light. So when you mix things together and it produces light, or it produces heat, or it gets cold, or it explodes, any of those would be an sign of a chemical change. Okay? Any questions? All right, if you will at this time, kind of practice some of the worksheets and things, and